Okay, so hopefully you guys had a little bit of time to review those videos about ArcGIS. You kind of know how to navigate your way around them. Today we're just gonna see how to do some applications. But before I do that, remember I told you the best idea is to do an analysis in every other software that you can, create a file, and then put it up on ArcGIS. Right? So that's the mentality that we're going to focus on today. We're going to present a bunch of things about unemployment and what? The what? Oh yeah, that would help, right? Okay. All right, so as I was saying, we're going to do some analysis to come up with different attributes for the United States, and then we're going to put it on the same template. And I'll also give you anything you need to complete homework number 5, which will be a similar thing, but only for Louisiana. Before we navigate into the VM, let's go ahead and go to this. So we're working on daily task 225 2019. So let's go ahead and navigate to this repository. And here we're going to download a bunch of things. First, let's download the analysis 1.3. And once again, it makes a lot of sense to create a new folder, name it something, and drop that one there. And we'll see it needs some data sets, so we'll download them as well. Now, one thing that I don't know if I have mentioned in the past, I think we did talk about it a little bit when we were discussing code names. So this specific code is named _1_3, analysis 1.3. Okay. And I think I opened up the wrong one. Yeah, I think I opened up the wrong one. Give me a sec. No, that's the right one. That's not the one that I want, though. Yeah, that's fine. I think we've used this in the past. That is not the right code. That's okay. I think we've already done this, right? More or less. No. Okay, now I remember. This is 1_3 for a reason. If you look at the first few lines, it is the code that we were working on last week. But then I started adding a bunch of things to the point that now the code is an increment of what we did last time. I changed some column names. I found averages. I did all sorts of things. Since I want to keep the old code that did something specific, but I also want to create a new one and save that one, I keep the same one as the initial thing. Those kind of do the same thing. They work on the same object. They output something similar. But then I had version 1, 2, and 3. This is 3 version. It does a lot more. So the idea is, if you're working on the same data set, if you're outputting a similar thing, the first number should be the same. And then increments or improvements on that code are captured by the second number, 1, 2, 3, 4, 5, 15. That doesn't end, right? The moment that you either add a new data set, switch things around, do something completely drastic, then you go to 2_1. Okay? All right. So again, this code will read something from a whole repository, and I want you guys to download this repository here on Google, this whole thing that it says TL 2017 US data. So download this whole thing. save it in the same file, and don't forget to unzip it. Okay, say it again.
TL 2017 US state. That's the one
Yeah, the one that says TL. Right. Let me navigate back. I'll show you in a second. The folder TL 2017 US state. Make sure you save that when you download it. Make sure that you unzip that into the same folder as the previous one. So in my case, I'm actually going to go and find it in my Google Drive. What the heck is it? Alright, so you should have a folder that looks like this. I mean, I have extra stuff in it, but you should definitely have analysis 1_3, and then that little folder TL 2017 US state. This is the same data set that you guys used a couple of weeks ago. I just cleaned it up a little bit and just kept only the stuff from 2017. I think we also had to do one of those, but since I'm unsure of what the output of yours was, let's go ahead and use that one, okay? All right, so do you see something like that in there? Like a bunch of files, one of which is a shapefile, and some database files and so on? All right. So if we focus on the analysis 1_3, the first line of interest after loading the libraries and whatnot is reading in the data set. So once again, if you set your session to working directory and your working directory looks like this, let me just shove old stuff somewhere so that it looks similar. Right, so you should have a TL 2017 US state, a subfolder in that folder of analysis, and then your analysis 1_3. If you look at this line of the code, line number 4, it asks R to read a database file not on the same folder as your code, but in a subfolder inside the same place. So remember what I told you in the beginning, that R is reading files relevant to where it is if you set the session up there. So by putting this little dot slash and a name, I'm actually telling R, go to where the code is, then in the same folder, look for a folder named TL 2017 US state. And in that folder, find this file. Okay, so this is how you can move down a directory, as we say inside R. You put a dot slash, dot means the directory you're in, slash go to this subfolder and then find the file in there. It is a good thing, I don't know if I've mentioned it before, if you keep all your data in one area, all your codes somewhere else, and all your outputs in a third place. So when I run this part, you should run it with me, you probably get a database file translated into a data frame that kind of looks like this. Now, these 4 lines of code, we did it last time. This basically just adds those 2 characteristic variables that we put if you're greater than the average for water and for land. Okay, if I run that, now I'm with 16 variables. So run all the way down to line number 10. That was the old code. We did that last time. Right? Now, go back to the Google Drive and download the extra file that you see over here called High Unemployment States 2016-2017. This is the database file that you created a couple of weeks ago. So download that part and keep it in the same folder as the other one. So download it in the same folder as the analysis. If you'd like, you can put that also into the other subfolder, but even if you leave it over there, it's still fine. It's called High Unemployment States 2016-17. It's a CSV file. All right, so download it, save it in the exact same folder. So now you should be looking at something like this. Analysis 1.3, High Unemployment State 2016-17. And then, is everybody on board? Should I wait a little bit? Do we get that working? Everybody? Yes? Okay. Now, let's go ahead and read that in by using line 12. That reads it and creates data frame number 2. Again, if you are to move this guy into the other folder, you can do so. Just make sure that when you're asking R to read it, to put the appropriate, target path. If you look at data frame 2, this one has this annoying first column, which is the row names. And if it doesn't have any row names, R will just put 1, 2, 3, 4, 5, 10. I actually don't need that. And there are ways to just ask not to do this. But we can also practice how to remove a row. And if you notice also, the very first line is, corresponding to the United States. Again, I don't really need that information. So here is a quick command to remove both the first row and first column. So if you use line 13, this removes the first line and first column from the data frame and appends it on that data frame. Okay. As you see it, it's df2 -1 -1. -1 corresponds to rows, -1 corresponds to columns. So now if you check df2 again, it doesn't have the first row and it doesn't have the first column. Yes, ma'am.
I added the / and then the folder, and then now it's not.
You have to move then the document in that folder.
It says she should use the slash in different position because of map.
So do you use / or backward / or whatever? Or Mac needs a different slash?
As like Linux, it's different sign.
No.
Didn't work?
No.
Did the other one work? The df1 read?
It worked before I added the / and dot. This one? No. Now that I added it.
Go back into the folder that you saved everything?
Yeah. Yeah.
Go back here in session. That one. Go files. Scroll down. Not in the right.
What does this mean as is? working directory I found is similar to that.
Yeah. It should be here. Oh, but you know what? It might be this way. Okay.
We may take them.
Then download it.
Okay.
That might be what it is.
Alright, so you need to open up that now.
Yeah. Yeah. That's the one it's open.
It's not that one.
It's not?
Just do that one. That one. Well,
Yeah. That's why I'm confused. But I think it's just because I added other stuff in the file skeletons. So let me just fix it.
go to this guy. That's the first one.
It's because I don't have this other file. I mean, I guess I do because it's right here. Here.
Okay, so just keep it like that for a moment without any. There's probably an issue with I don't know.
What is that? As is equals to plus, what is that?
Right, so the database file has a certain metadata attached to it, and if you put as is equals true, it will keep all that metadata on top of it, which we don't need. The only thing we need is we need the CSV file, the raw rows and columns and numbers in it.
So this one removed the first and second row, and I only also need not all the columns, I need the columns from 1 through 10. So to do that in a fast way, you say df2 equals df2, and then you enumerate which columns you want, put a semicolon in between. Notice here the syntax, this is everything, comma, so all rows, comma, columns from 1 to 10, right? So always you need to tell R which rows and columns you want to keep. If you don't put any rows, it keeps all the rows. If you want to put the columns this way, 1 through 10. If you want to put more columns, 1 through 10, and then 13, to do that you put C, 1 through 10, comma 13. Right? You write something like this. Right? So this is going to keep the columns 1 through 10, and then the column 13. Actually, let's go ahead and keep the column 13. Well, actually, no, we can't, because that's going to mess things up later. All right, so now I only have 10 variables. I basically dropped some of the arguments that I didn't need. Then if I go ahead and check df2, as you can see, it's got all sorts of big names, and we saw that as well when we were creating that database last time. Some of these folks went all out and wrote the whole sentence. Okay, so basic idea here is to keep the names informative but also simple. Right? And you can change the name by invoking the command call names df2. If you just run call names df2 on its own, you're going to get the names that are there. If you put call names df2 equals something, that something is going to replace the old names. So grab line 16, please, and run it. This will replace the names for df2 with the ones that I put up there. Employment 16, unemployment rate 16, employment 17, employment rate 17, and so on and so forth. Still informative, but much simpler than the ones that we started off with. Okay? Everybody okay with that? Now, we have two data frames, and we learned how to merge them into using PostgreSQL. But you can also merge them in R. Okay? And the command to merge things in R is, well, merge. Okay? And there are various merges. You can make sure that everything is used from the first. You can make sure that everything is used from the second. You can make sure that everything is used from both. You can make sure that you only merge the intersection. I'll let you check the syntax of merge on your own. Right now, what I'm trying to do is I'm going to try to merge everything that I see on df1 with as much as I can from df2. Okay? And you need to also specify which column you're using to merge things with. Both data frames now have a column that stands for name. Okay, in data frame 1, there's a column name that stands for the name of the state. And in data frame 2, there's another column that also corresponds to name. So what I'm doing is I'm merging both of them, df1 with df2, by the column, the shared column name. And now I come up with a new data frame that has 25 variables. 16 from the first and 10 from the second, but don't forget one is common, both of them, so you have 35 variables.
So what is that R.X?
Right. So all.x makes sure that all the data points from the first data frame are used. And if you don't have something to match them from the second data point, it's going to put empty. So I'm making sure that df1 had 56 observations, right? df will also have 56 observations. It's going to use all df1 and then try to attach as much as it can from df2. If it doesn't match, it's just going to put empties. If I had done all.y equals true, it would be df2 is the template and you try to match as much as you can, right? Because in a situation where you try to merge things, it's not the case that they're going to match up completely, right? So with all.x true, I'm saying make sure that you use all the information that you see in the data frame 1 and match as many as you can from data frame 2. All right, so now you have this data frame. Let's open it up real quick. That has most of the states full all the way to the end. But for example, Commonwealth of the Northern Mariana Islands. This was in data frame 1, but it was not in data frame 2. So at the end, you just see a bunch of NAs. That one was not matched. It's still kept in the data frame, but it just doesn't have any information coming from df2. Similarly, I guess American Samoa does not have anything in df2. It's still kept, but it only uses the information from the first data frame, not the second.
That's what all X do.
Correct. All X means use the first data frame. All Y means use the second data frame. All true, use both data frames. Okay, so then what I want to do is, again, I want to create two character variables for unemployment in 2016. I want to put all the ones that had high unemployment with a 1 and all the ones that had low unemployment with a 0. So run lines 18 through 20, and you now have two extra variables. The df char UR16, which is going to be at the very end. And it's 1 if you're above the average, 0 if you're below the average. Similarly, I want to create df char for the 17. And again, I have now an extra variable here, which is 0 for the one that had low unemployment, and 1 for the ones that had high unemployment. All right. Now, I want to save all this. Use line 24 to write it as a DBF. Notice that now you have an extra DBF file down there. All right. What we want to do before we continue on is grab that DBA file and put it in our folder to replace the old one. Okay, so here's the idea. I took the old database file, right, and I took an extra CSV. I merged them together and created a new database frame with the old title. So then I grab that one now and put it back in here. It's going to say, would you like to replace it? Yes, replace it. Okay, so you could theoretically do this whole thing in PostgreSQL. You could do this whole thing in ArcGIS. But I promise you it's much harder to do it in ArcGIS than it is to do it here. So that's the mentality. Use whichever software is easier to do things. All right? I would argue also it's much easier to do it in PostgreSQL if you have both of them there. But now that I had one in database file, the other is a CSV, I just use all. The code continues on a little bit. A very useful command, I think I've talked about it already, is summary. Summary in R, if you just drop a data frame in it, just give you a max, min, and all that for a specific data frame. So if you run the last 3 lines, you get a summary. And the idea is you would like that summary to be saved as a file. You can do that easily with sync. In R, if you put sync in the name of something and end it, instead of outputting things in the console, it outputs them in either a text file or a CSV or something like that. Why that can be useful? Well, now that I saved it as a CSV file, it might be, a little bit easier for me to read it or copy paste stuff. Okay, so if you put sync, as I put here, sync summary text, everything that follows it and right before the sync ends is going to be saved in a TXT. I may want to put CSV and run this part, and now it's going to be saved in a CSV file. Okay, I don't know if the first is easier than the second, but let's say the TXT, you can open it up with Word, you can make it look nice, so it's a fast way. If you don't do that, if you just run this line, the summary df, you'll see the summary for every column in that data frame. Okay, and interesting stuff here, you get the max, min, median, first, and third quartile. So it's quite fast, and you get all of them for free. All right, the main object was for us to generate this, where's it at? To create this database frame. So grab that one and drop it in here and replace it. All right, fantastic. Are you with me so far? Did we all now create a new folder that had all the previous files, but now an extra DBF, an updated DBF? Yes? Now, navigate to ArcGIS through the VLAB, and we'll use that folder to do things. Perhaps you might, since we're going to be uploading a bunch of stuff on the VLAB, perhaps you want to push on your Google Drive this whole folder, the TL 2018 US state. Right? Put that up there somewhere. Right? So let's spend a moment doing that. The TL 2008 US state, put that somewhere in your Google Drive because we want to download the whole thing on the VM and do stuff with it. While you're doing it, let me go ahead and go to the VM, and I'll answer some questions of the ladies in the back. All right, so make sure the updated TL 2017 US state is somewhere in your Google Drive, and then also navigate to the VM. Oh, don't do this to me. Yeah, okay, so I had this problem yesterday. It seems that it persists. Yes.
Not that one.
Yeah, so I had that for like the whole day yesterday. Well, anyway, I mean, we'll figure it out. I can navigate you through it, but I'll have to be looking at somebody else's thing. I don't know what's going on here. Anyway, all right. So I might, yep. So something to do with my client. I haven't updated it for a year, so maybe some sort of like. See, I knew that it was the case. Anyhow, so go ahead and pull up your download everything again on the VM, create a new folder. Okay, so hopefully
Drag and drop this file.
this will be there. Drag and drop works on some computers, not on everything. The SSH file should work exactly. Not always. So save it somewhere, perhaps in the same folder that you used last time. If that is not there, new one, and definitely connect to the desktop that has ArcGIS.
The latest version should be the one that we target. And now what we're going to do is a similar thing like last time. We're going to put that up there. It's just that we have a lot more columns to play with. And some of these columns are numeric. And we're going to do all sorts of things on top of them, like pie charts, histograms, you name it. ArcGIS is great if you want to do, if you want to create pictures, if you want to create maps, if you want to create basically eye candy. I strongly suggest you use that if you're going to be doing any sort of mapping anywhere, and creates great outputs. They look very nice on posters and all. I've used it only once to do real research, basically using neighboring cells, and that's just it. I'll be honest with you. I have used QGIS more than once to do real research, so we're going to spend one day tomorrow just talking about QGIS. You'll notice that it's exactly like ArcGIS. Why do I talk about ArcGIS more than QGIS? Is because the Ag Center always uses ArcGIS. Like all your professors are going to use that anytime you do a map, right? You go to industry, everybody's using ArcGIS. All the consultants that give people, you go out in the field and you're talking to a farmer, they're using ArcGIS. Yes.
If you wanted to use ArcGIS, like let's say you were given an area of land and said find a certain plot that matches these attributes.
Yeah, that doesn't work.
Would you do that on an outside, or you wouldn't?
You can't do that on ArcGIS. You can do other stuff. You can give me an area that matches those coordinates. Give me an area that matches, that shape. But you can't just say, here are the attributes, find me an area that matches those. What you would do, you would have to write a whole command of what does that area mean in terms of attributes. You can somewhat do that. So you'll have to go and say, take that many rectangles and find, we'll do one which is very simple. Find me all the rectangles there with a certain property. So you would have to go in and say not just the rectangles with this property, but also the rectangles that are close to each other.
Okay.
So it is possible. I just
You do something like that as a real coding.